A polynomial p is given. Factor p into linear and irreducible quadratic factors with real coefficients. And then b, factor p completely into linear factors with complex coefficients. Now, I can do this with a u substitution, but since I did u substitution on my last video, I'm going to do it using the rational root theorem. So my rational roots are going to be plus or minus the factors of 9 over the factors of 1. So it's going to be 9, 3, and 1 over the factors of 1, which is just 1. So it could be plus or minus 9, 3, or 1. So I'm going to choose 1 to begin with. And I'm going to synthetically divide. So it's going to be 1, 0, 8, 0, negative 9. Which ends up giving me 1, 1, 1, 1, 9, 9, 9, 9, 0. Now, I know that x minus 1 is going to be a factor, and the other factor now looks like this. So I'm going to do negative 1 now. And this becomes 1, negative 1, 0, 0, 9, negative 9, 0. Remember, this one doesn't count because it's the remainder of the last one. So now another factor is going to be x plus 1. And then the rest is going to be x squared plus 9. Now this guy right here is an irreducible quadratic, mainly because if I solve him, subtract 9, you end up getting imaginary solutions, because the square root of negative 9 is 3i. Which means that this right here will satisfy my first part, which is linear factors, a set of linear factors and irreducible quadratics. Now, for the next part, it says I want all linear factors, x minus 1, x plus 1. Now this factors out to be the same thing as if I found the zeros of this, because the factor theorem says the zeros of this will also create factors. So if I have a 0, let's say c, my factors will look like x minus c. So my c's are going to be 3i and negative 3i, which means my factors are going to be x minus one of them, and then x minus the other one, negative 3i. But minus a negative is actually just going to be positive, so I'm going to rewrite this as x plus 3i. So this is factored in all linear factors, and this one's factored in linear factors and irreducible quadratics. An irreducible quadratic is a quadratic that cannot be reduced into two integers. So x minus an integer, that is not an integer, therefore this is an irreducible quadratic.